Okay, we are now going to look at grouped frequency distributions. And this is by far the most involved procedure that we're learning here when doing frequency distributions. And so there's several methods. I've seen textbooks teach this in different ways. I don't like the way that the MLA textbook that we're using presents this. It's not my favorite, so I'm going to teach you another way, and I just think this is a little more helpful, more insightful. It's not that much more difficult. Now, when you follow this procedure, you will get a right answer, and I like that because then, you know, if you do it, you can check and make sure you're doing it right, okay? But there's other ways you could make the histogram, as long as you follow the rules and the class widths are the same, and you know, you don't have gaps between the classes, there's no overlap. You're fine. You know, you just got to be able to split up the range into your intervals. You got to get your classes so that they're all the same width. So it's not that this is the only way to do it, but this is the way I'm going to want you to do it, and that way you can check and make sure you've done it right. Okay, so notice when I tell you to make the histogram, I give you one bit of information, and that is I tell you how many classes to use here. So it says construct a frequency distribution using 7 classes. So the first thing you need to do is determine the class width. So like the college tuition example, the class width was like 2,500, okay? So what we need to do is determine the class width for this distribution using 7 classes. So what I'm going to do is show you the formula for that. So class width, okay, this is equal to the maximum value in the data set minus the minimum value in the data set divided by number of classes. Okay, so by number of classes here, I mean this number that I'm going to give you. So in real life, you would decide how many classes you wanted to use. Okay, but for the problems you're going to be given here, I'm going to tell you how many classes to use. And you're going to put it into this formula. So for the example here, my class width, here, the maximum value is 170, and the minimum value is actually 6. Okay, so this one is the max, and this one ended up being the minimum. Okay, so I'm going to take 170 minus 6 divided by 7. We're going to use 7 classes. Okay. Now you need to be really careful when you put this in your calculator. If I did 170 minus 6 divided by 7, is that going to give me the right answer there? And the answer to that is no, not in this case, because this is going to do the order of operations. It will divide first and then subtract, and you don't want it to do that first. You want it to subtract first and then divide. So I either need to put parentheses around the 170 minus 6, or I could do this in 2 steps. 170 minus 6, hit equals, and then divide the difference by 7, hit equals. And you see I get 23.428, so on. Now, I'm going to want you to use a whole number. So this data is whole numbers, and so I want this to be a whole number. Okay, usually you want your class width to have the same number of decimal places as your data set. Okay, and to keep things simple, I'm going to always have our data set be whole numbers. So now, normally I would round this to 123 because of the 4 here is less than 5. And so you would normally just round that down to 23, but we're going to always round up here, and that's important. We're going to always round up to the next whole number. Okay? Let me try to explain why this is, because this will also help you understand what we're doing with this whole class width, because it's really not that difficult to understand. Okay? Let me just give you kind of what's going on. Okay, so let's say this is the minimum value of a data set and this is the maximum value, right? And let's say we're going to want like 5 classes. 1, 2, we'll say 3, 4, whatever it is. We're going to want 5. We're going to want 5 classes. So what that means here is, in the end, I'm going to want to have like 5 bars. Okay, and I don't know what these bars are going to look like until I'm done with my graph. But the point here is that the distance between the minimum and maximum, that is actually your max minus the min. And they call that the range. This is actually the range of the data. The range is just the distance between the minimum and maximum value. And so the class width here is that maximum minus the minimum. It's that distance divided by the number of classes, right, that you're going to use. And so what I'm doing is I'm taking this distance and breaking it into 5, or in this case into 5 pieces, right? And that's going to give me the kind of the width of each of these classes. You're breaking that distance when you divide by 5. And that's how you get the class width. So it's not rocket science here or anything. But let me show you what would happen if I ended up taking this and rounding it down, like before, if I rounded down to 23. The actual number that you get is exactly what it would need to be so that you would reach the maximum value. Okay? If you rounded down, each of these bars would be a little too short, and you would fall short. That maximum value would not fall into the 5th class in this case. Okay? And that's a problem. You'd have to add a 6th class in order to get that maximum value. Okay? But if you always round up, then what you're going to do is you're going to overshoot each one, and that maximum value will fall into the last class. It's not going to end on the last class, but it will fall into the last class, and that's okay. It does not have to end on the maximum value. You just need the minimum value to you need the first class to contain the minimum value, the last class to contain the maximum value. So that's why we always round up when we do that. Okay? And that's also where that formula comes from. Okay, so now what I'm going to do here is I'm going to make a frequency distribution table. And then this is going to be, I'm just going to give these some names here. I'll call these class limits. And this is going to be the tallies. You'll see what that is in a minute. And this is going to be the frequencies. Okay? So now, what I'm going to do is I am going to start on the minimum value. And then my class width here is 24. So I'm going to add 24 to 6. And now this is important here. When I add 24 to 6, I get 30. But that's not going to be my upper limit here. It's going to be the next lower limit of the next class. So it'll be the lower limit of the next class. This upper limit is going to be 29. It'll be one less than that. Okay? And so now that means this class will have exactly 24 values. So in other words, the difference between these is actually 23, but the number of values in the class is 24 because it includes the 6 and the 29 and everything in between. It's a little confusing that your class width is not the difference between the upper and the lower limit. What it is it's actually the class width is the difference between two lower limits. Okay, between 30 and 6, and you get 24. Okay, so what you do then when you do this is you add 24 to this to get the next lower limit, and then you subtract 1 to get the upper limit, like that. Then I add 24 to this to get the next lower limit, and then I subtract 1. Then I add 24 to this, and that's going to give me 102, and then I subtract 101. Add 24, 126, and then subtract 1. That would be 125. And then I'm going to add 24 to this, and then that would give me 150, and then I would subtract 1. I'm going to add 24 to this, get 174, and then I subtract 1. And then notice my maximum value falls in the final class. So I actually don't need that 24. My table ends here, and indeed the maximum value belongs in the 7th class. We got 7 classes. The maximum value is in the 7th class. Now, one thing here is, this does not happen very often, but if your class width is small, sometimes you can overshoot the maximum value, and then your maximum value would occur in the 6th class. Does not happen very often, but if it does, it's not wrong. You could just use 6 classes. There's nothing wrong with that. Okay? So, those are my classes then. So what I got is I have 7 classes. They all have the same width, which is a class width of 24. They all, there's no gap between the classes. They all go right up to the next one, and they don't overlap at all. So exactly what I need. Okay? So now what I have to do is I have to find out how many observations are in each one of these classes. And what I've found is it's very difficult if I go through here to find all the ones between 6 and 29, and then between 30, and this should be, I'm not sure why I did that. This should be 53. Wow. So you probably were screaming out when you were watching the video. That should be 53. I think I did, yeah, I did the other ones okay. I'm not sure what I did there. So instead of trying to pick all the ones out that belong in each class, what I'm going to do is I'm going to go through the values one at a time, and I'll put a tally mark by the class. So 44 would belong in here, 170 would be there, 6 would be there, 39 is here, 44 here, 43 here, 27 is here, 30 is there, 44 is here, and then 21 would be there, 78, 82, 31, 42, 50, 66, and then 37. And so it'd look like that. So my frequency here would be 3, 10, 1, 2. It looks like I would have 2 classes that don't have any data, and then 1. Okay? So, so these tally marks are just there to help you get the frequencies. Okay? Now, include the frequency column. That's important, especially if you have a lot of tallies here. It would be kind of hard to compare these if they were all tallies, right? And so you want the numerical, you want the numbers here so that you can go down and compare the data. Okay? Also notice that even if there's no data in the class, you still include it in the table. Okay? Because you want spaces in the table where there is no data. You want the people to see that, yes, there's part of this data set where there is no data. Okay? It's just as interesting that there's no data here that there's it is that there's 10 observations here. Like, this is the class with the most data. These are the classes with the least data. Okay? They're both interesting. Okay? And then this one over here, this would be like an outlier, wouldn't it? It's lying outside the rest of the data. Some president made 170 vetoes. Yeah, and I guess I didn't talk about that. This data set is kind of interesting. This is the number of vetoes for a sample of past presidents. Okay? Kind of an interesting data set. Okay, well, I want to make sure I got them all. That's another thing here. I should add these to make sure I got all of the data. So that would be 13, 14, 16, 17. So I have 17 observations, and if you notice here, if you count them, I have 17 observations here. This is 6 by 3, which would be 18, but this one doesn't have any. This row only has 5 observations. So I'm good. I got all of the data there. Okay, so that is the frequency distribution table. So now let's talk about making the histogram here. Okay, we're going to put the classes along the bottom. So I have 7 classes, so I actually want 8 tick marks. 1, 2, 3, 4, 5, 6, 7, 8. And now, when you make these bars, we're not going to center them on these marks. We're going to go from one to the other here. Okay? And what I'm going to do is I'm going to label these with the lower class limits. So this would be 6, 30, 54, 78, 102, 126, 150, and then this would actually be 174. You don't put 173, I'd put 174. It would be the next lower limit. It would be the lower limit of the next class if there were a next class. So all of these are the lower class limits. Okay? And then these are the frequencies. They're going to go up to 10. So I'm going to do a mark for each one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then maybe I'll just label 2, 4, 6, 8, 10. Like that. So it's not so crowded there. And now this first class goes from 6 to 29, and there's 3 observations. So this will go up to 3, and then I'm going to bring it up to 30. Now you're fudging a little bit here because this doesn't go all the way up to 30. Okay, it goes up to 29, right? And then the next one starts at 30, and that one goes up to 10, and that'll go all the way to 54, but it really goes up to 53, and you're fudging a little bit, and so then you this would be 54 to 77. So 54 to 77, that would have 1 observation in there. So this would be like this, and then you would have one with 2 observations, and then 2 with none, and then 1 more with 1. So, and then I'll shade these in. And notice if there's no data there, then you want a space. Oh, I am sorry. Let me bring it out here. If there's no data there, then you want a space there. Okay? And showing that there's no data. And notice all these bars are touching then. They share that boundary, and it goes from you're actually labeling not the center of the bar, but you're labeling the lower end point of each of the classes. And so you can kind of think of this as 6 all the way up to but not including 30, 30 all the way up to but not including 54. And so if you actually lie on that boundary, you belong in the next class up. That's a way that you can think about it. And then, yeah, am I done with my histogram, or have I forgot something very important? And you're right, I forgot a title and labels. Okay, so I would label this number of vetoes for sample of 17 past presidents. And that's just how I always label it. I always state the total number in the sample. Okay? So down here, this would be number of vetoes. Okay, and this is the frequency, but what does the frequency represent? Each one of these numbers. So that represents the number of presidents that lie in each of those categories. So I would label this number of presidents. And so then things are very clear here. For example, between 60 and 30 vetoes, you had 3 past presidents. Between 30 and 54, you had 10 past presidents. And so on. Okay? So that would be the histogram. And then finally, we can state the shape of this histogram. So I can kind of draw a light line through all of these if I wanted to. And then you can see that there's this outlier. And it's on the right. So this would be a right skewed data set. And in fact, this is very right skewed, because that is actually lying 2 classes beyond the next biggest value. Okay, so there you go, there you have it. That's the grouped frequency distribution. Real quick here, for the class width, you just take the maximum minus the minimum, divide by the number of classes, and I will always tell you what number of classes to use. And then to make the table, you start with the minimum value, you add the class width to get the next lower limit, subtract 1, add, subtract, on down the line, and then you can use the tallies to find the frequencies, double check by adding them up, and then on your histogram, these are your different classes, and along the bottom you're going to label the lower class limits, and then the height of the bar, it'll go up from the lower class limit up to the next class, and the height of the bar will tell you how much. All the bars are touching. In a sense, they share that boundary. You kind of fudge a little because this just goes up to 29, so you're fudging at what happens between there, but that's okay. For our class, that's fine. There are ways that you can make that even more accurate, but we're going to just say that's 6 all the way up to, but not including 30, 30 all the way up to, but not including 54, and so on. And there you get your histogram, your visual picture of the data. So we're going to do another one of these on the next video, but I'm going to have you pause the video, and I want you to try to do the frequency. You find the class width, do the table, do the histogram, see how you do. You can start the video back up, and then I'll go ahead and you can check your work, see how you did. So, okay, that's coming up next.